Here is a combined summary of the 2 pages. Sentence encoders are a crucial component in natural language processing, enabling key downstream applications such as classification, clustering, and retrieval. The mainstream neural architecture for NLP, the transformer, has unfolded into different families of encoder-decoders, decoders, and encoders. Despite the visibility of decoder models, encoder models have maintained competitive performance in non-generative tasks, particularly in classification tasks. Sentence encoding, or sentence embedding, is a necessary step in determining the degree of semantic synonymy, similarity, or relatedness among linguistic expressions. A prototypical use case is found in semantic-driven information retrieval, where the input query and relevant snippets are screened and selected based on their meaning representations. However, the typical approach to comparing sentences using a regular encoder has the drawback of requiring a large number of comparisons, which becomes intractable for large volumes of data. To address this, standalone sentence embeddings can be calculated using a Siamese encoder, an approach introduced by SBERT, which has become known as sentence encoding. Given 2 sentences, they are fed, one at a time, to the same encoder, and the resulting embeddings are pooled and passed through a loss function designed to bring closer together in vector space the embeddings of semantically similar sentences. Most NLP research focuses on English, leaving a lack of competitive and open sentence encoders specifically developed for other languages, including Portuguese. To address this, the authors present Serafim, a family of sentence encoder models, available in different sizes, that establish a new state-of-the-art for the respective core benchmarks of semantic text similarity and semantic textual similarity. The research focuses on open sentence embeddings for Portuguese, aiming to improve information retrieval (IR) in the Portuguese language. It discusses related work, including sentence encoders not specifically for Portuguese but multilingual and English models. The selection of models is based on their performance in the SBERT site and the MTEB benchmark. The STJIRIS family of encoders for Portuguese is also introduced, which includes models like IRIS-STS, STSB, ASIN, and ASIN2, trained using masked language modeling and TSDAE methods. These models are chosen for their high performance on various datasets. The paper also mentions other models available on Hugging Face, such as JM Brito, PTBR Similarity 5 Small and MTEBPT, but they are not considered due to lack of peer-review-ed publications or performance scores. The methodology follows the SBERT architecture, focusing on developing new training methods for sentence encoders. The research paper discusses the development of open sentence embeddings for Portuguese, focusing on supervised and unsupervised training methods. Supervised methods include the use of 2 types of training. One based on pairs of sentences annotated with similarity scores, utilizing loss functions such as cosine similarity, cosent, and angle. And another using pairs or triples of semantically close and negative sentences, employing the multiple negatives ranking, MNR, and gist embed losses. The authors opted for gist embed due to its better performance in trial experiments. Unsupervised methods were also explored, including the transformer-based sequential denoising autoencoder, TSDAE, and contrastive tension loss within batch negatives, CT. These methods do not require labeled data and are used as supplements to supervised methods. The final Serafim models were developed through sequential transfer learning, involving 4 stages with different types of data. The process began with pre-training base encoder models using CT loss on high-quality Portuguese corpora. Next, the models were trained for 10 epochs using gist embed on NLI datasets converted to triples. The validation splits of STS datasets were combined and used to select the best model checkpoint. In the 3rd stage, the models were trained for 20 epochs using cosent and angle loss functions separately on combined STS datasets. The best performing model was chosen based on validation set performance. Finally, the models were trained for 1 epoch on a large information retrieval dataset using gist embed, resulting in the Serafim models for information retrieval. The paper also discusses the raw text data used for unsupervised training, including several Portuguese corpora from the Opus collection. The choice to use only the Portuguese part of these parallel corpora was made to focus on the target language. The paper discusses the development of Serafim, a family of sentence encoders for Portuguese that leverages pre-trained language models. The authors utilize monolingual and multilingual datasets, including EU Bookshop, Europarl, TED 2020, Tatoba, and labeled datasets like ASIN, ASSIN2, STSB Multi-MT, IRISSTS, PLU, and MMARCO. These datasets are crucial for achieving top performance in sentence encoding tasks. The authors also highlight the importance of fine-tuning foundational models for sentence encoding, as this process significantly improves performance. Their experiments show that Serafim outperforms previous encoders for Portuguese by a small margin and multilingual or English-specific sentence encoders by a large margin. The paper emphasizes the significance of Portuguese datasets in achieving high performance in sentence encoding tasks. It also underscores the need for fine-tuning foundational models to produce top-performing sentence encoders. Overall, the authors demonstrate that their family of encoders, Serafim, is the state-of-the-art for Portuguese, outperforming previous encoders in various test datasets. Here is a combined summary of pages 9 and 10 of the research paper. The authors present the results of their sentence embedding models for Portuguese, showcasing the performance of their Serafim models on various datasets. Table 3 displays the results on STS, with Spearman correlation coefficients, where the Serafim models outperform previous sentence encoders for Portuguese, as well as multilingual and English-specific alternatives. The authors note that separate training for Portuguese variants could lead to improved performance, and that larger encoders tend to outperform smaller ones. The authors also explore the performance of their models on the IR task, with results presented in Table 4. The Serafim IR models, trained using the MMARCO data, achieve state-of-the-art results on the MS-Marco testset, outperforming previous encoders for Portuguese and multilingual and English encoders by a large margin. The authors observe that the larger Serafim models perform better, except for the IRISSTS dataset, where the smaller 100M model outperforms the larger 900M encoder. The authors attribute the superior performance of the Serafim models to their ability to adapt to specific domains, with the smaller model performing better on the IRISSTS dataset, which is of a specific legal domain. They also note that the datasets offer different levels of difficulty, with some being easier to resolve than others. Overall, the authors' Serafim models set a new state-of-the-art for Portuguese sentence encoding, demonstrating the effectiveness of their approach in capturing semantic meaning in Portuguese sentences. The paper discusses the development of open sentence embeddings for Portuguese, focusing on the creation of encoders with varying parameters. These encoders are designed to serve both the European and American variants of the Portuguese language. The authors present several models, including Saint Giras, Albertina, and Bertimbau, each with different parameter sizes. They also mention future work, aiming to enhance the encoder's performance by exploring data augmentation techniques. The paper highlights the significance of these encoders in advancing the field of language understanding and processing in Portuguese. It also references various datasets and models, such as MS-Marco, MMARCO, and Sentence BERT, emphasizing the importance of multilingual and crosslingual evaluations.